Okay, Year 10, Equations and Inequalities, Foundation Part 2. Let's go down to these inequalities on the number line. And from yesterday, x, I can see x is on the number line. That's something to look for. And here it's x is less than 3. So I put a circle at 3. And I always put a line. It doesn't matter how far you go. Just to show that it's going in the same direction as this inequalities. That means it's less than 3. What I then have to do is decide, do I colour the circle in? I don't colour it in because it is not got an equals. So essentially that is the answer. If I look at 1 is less than or equal to x, which is less than 5. First of all, get my circles at 1 and at 5. Put the line in between to show that it's between, that x is between those. I have already checked for x here. And then I just need to look to see whether I need to colour any in. Because this inequality has got an equals, I colour this one in, but the other one hasn't, so that is the answer. Okay, question 3. Kat thinks of a number. She doubles it and then subtracts 5. Her answer is greater than 50. Write this information as an inequality using n to represent Kat's number. So, Kat's number is n. She doubles it, so she's timesing it by 2, and we would write that as 2n. And then subtracts 5, so it's 2n, take 5. Her answer is greater than 50, so the greater than is pointing away because it's the 2n is minus 5 is bigger than the 50, and that is it. That's the inequality. It then says, what is the smallest possible integer that Kat could be thinking of? Well, if I look at this, I've got 2n minus 5 is bigger than 50. If I add the 5 to both sides, I've got 2n is bigger than 55. Then I divide by 2, so n is bigger than, well, 55 divided by 2, half of 55, half of 50 is 25, half of 5 is 2.5, so what I've got is 27.5. It's n is bigger than that, and then it's using this word integer. Don't forget that integer is whole number. So all of the whole numbers bigger than 27.5, 28, 29, 30, forever. And of course the smallest one is 28.